Hi guys. All right, let's kick off Unit 2. And you can fill in the first thing on your tracker, which will be this Part 1 to 1 variable equations. If I go too fast at any time, you can always pause and rewind. So let's start solving some. This is the main foundation of algebra. Now this is meant to be a resource for people who need it. So if I'm going along and you already know all of this, you do not have to watch the whole video. Or if you think you're getting it as you go along and then you just want to try some by yourself, that's fine. Do it and then you can either pause the video and check it when you're done, or you can even just skip the whole video, do the work by yourself, but then I'm going to ask you to please go on JT Learn and check the key, because you have to know if you're right. And I'm going to do about 25 problems here, and they each have some little thing that's slightly different. So if you get most of them right, but a couple wrong when you check the key, then you just need to find out what is it that was your misunderstanding so you can go for perfect. All right, here we go. So the page starts off with you recalling some order of operations. Now this part I'm going to let you actually do by yourself, because this should be old review stuff. After you've come up with this part with the order of operations, then you need to look at Julie's work and Patrick's work and see if you can figure out who did it right. And it might be a little trickier than you think. So put your opinion down here. And you can pause this when you're done, or you can come back and do this, but I'm going to go ahead and go on now to the equations. So remember that we've got a variable and a bunch of stuff happened to it, and we need to undo those. So the order of operations have us doing things inside of the parentheses and then exponents, but mostly what we'll be focusing on when we're solving is multiplying, dividing, adding, and subtracting. So order of operations says we always multiply and divide from left to right before we add and subtract from left to right. So when we're solving, we're going to do inverse operations. So we're going to be doing that in reverse. First we will undo addition or subtraction, and then we will undo division or multiplication, because we'll be doing things inversely. All right. And then we're supposed to write our answer as a solution set. So that's just a notation. It's a way of writing it. So let's see. If I have x plus 7 and I want to get x by itself, I'll have to minus 7 from both sides. Because positive 7 minus 7 is nothing. So I'll have x equals, and 12 minus 7 is 5. So the solution set is 5. Set notation is just brackets. So for number 2, if I want to isolate y, it doesn't matter that it's on the right side of the equation. We can still isolate it. So we have to get rid of negative 4. The opposite of negative 4 is positive 4. So I'll be adding 4 to both sides. Negative 4 plus 4 makes 0. So we're trying to make 0 sets. So we've got y equals 14 plus 4 will give us 18. So that solution set is 18. Now in this case, when the 5 is attached to the a, they're multiplying. So we have 5 times a. So to undo multiplying, we have to divide. That looks like a fraction. 5a divided by 5. 5 divided by 5 makes 1. So I have 1a, and we'll usually just write it as a. 1a is sort of like beginner. You can write the ones if it helps you, but ultimately 1a just means a. So when we do this side, we've got to do the same thing to both sides. Negative 25 divided by 5 gives us negative 5. So a equals negative 5, and that's the solution set. All right, in this one, z is being divided by 6. So the opposite of divide is multiply. Multiply always happens on top. So I could do it on either side of the z here. So 6z divided by 6. 6 divided by 6 makes 1. But whatever I do to one side, I have to do to the other. So I have to multiply this side by 6. So I'll have 1z equals 21 times 6, which would be 126. So the solution set is 126. In this case, b is multiplying by negative 3. So sometimes this is confusing to kids that are beginning. When you're going to undo adding, you have to subtract. When you're going to undo subtraction, you have to add. When you're going to undo multiplying, you have to divide. But you don't have to divide by the opposite sign number. So if this is multiplied by -3, I simply have to divide by -3. I divide by the same number that's multiplying. So we don't have to switch signs or anything. So -3 divided by -3 makes +1. So I have +1b, or b. Divide this side by -3. Got to do the same thing to both sides. -72 divided by 3 is positive, because you're dividing by -3. Negative divided by a negative makes a positive, and that will be +24. And you can use your calculator if you need to, but 3 goes into 7 2 times. Carry the 1, so it goes into 12 4 times. So the solution set is 24. And here, now, we have some multiplying that needs to happen. So what I'm going to do is clean this up a little. This says A, and then there's always an invisible number outside the parentheses. If you can't see it, it's an invisible 1. So -1 times -4. Okay. So, number 6 is one where you might need to pay attention to a couple things. Watch this video. So, when you have, now I have multiplying and I have subtraction. So, what we need to do is clean this up a little. We'll go ahead and multiply these two numbers. So, we won't bring down a symbol. We don't want to bring down this minus right here and then deal with the sign of the 1 separately. What's easier is, think of that as a -1 multiplying to a -4. So we have our A, and then a -1 times a -4 gives us +4. So we have 14 equals A plus 4. And now we can get rid of that +4 by subtracting the 4. So 4 minus 4 is nothing, so A equals 10. Solution set 10. How are you doing so far? You might need to pause and think for a minute. This is going pretty fast, so you need to go at the pace that works for you. Alright, so this next batch gives us an opportunity to worry about these signs a little bit more. So when you have a fraction with a sign next to it, we want to put that sign with the numerator. So I'm going to rewrite this so that it says 12 equals -m over 3. So I know where that negative is. We'll never ever put it with the denominator. Okay, so -m is being divided by 3. So to undo that, I'll go ahead and multiply by 3. Whoops, what's that all about? Go ahead and multiply by 3 to both sides. So 3, this will be -3m. 3 over 3 makes a 1. So I'll just have the -m left. 3 times 12 is 36. Now, that negative, when it doesn't have a number showing, it has an invisible 1. So if you want to think of this as -1m, you can put that in there. But the bottom line is, if you have a -m, you're not done yet. So -m is not solved. -1 touching m means they're multiplying. So to undo multiplying, I will have to divide by -1. So when I divide both sides by -1, -1 divided by -1 makes a +1. So 1m equals -36, because 36 divided by -1 changes that sign. So the solution set's -36. Those negatives are usually the trickiest part of math all the way up through your senior year. Okay, so we've got 4 minus b. Well, a lot of people see this minus and they want to add under here, and that's not how it's going to work. Because what we want to get rid of is the 4. And the 4 is positive. So to make 4 go away, we're going to have to minus 4 from both sides. So we'll minus 4. So now we have to not lose track of what we have. We have -b, or -1b, equals, and if you have -8 and you minus 4 more, you're going to have -12. Now remember, -b means we have a -1 multiplying to a b. To get rid of multiplying, we'll divide by that number. So negative divided by negative makes positive 1, so b equals negative 12 divided by negative 1, give us positive 12. All right. So this one, we've got multiplying and addition happening. We always do inverse operations. So first we'll get rid of any sort of adding or subtracting. So to get rid of plus 4, we'll minus 4. Got to do it to both sides. So we'll have 2d equals, and 12 minus 4 is 8. Now we have 2 multiplying to d. So the opposite of multiply is divide. 2 divided by 2 makes 1. So we have 1d. Divide to this side. Got to do the same thing on both sides. 8 divided by 2 is 4. So the set notation would be 4. Okay. Why don't you... Nope, I better keep helping here just in case. If you know how to do it, you go ahead and you can check this afterward or go to the key. But I better make sure I have a walkthrough here for anybody who needs it. All right. So again, we have 5 and then we have minus 9w. So the 5 is positive. To get rid of it, we're going to have to minus 5. 5 minus 5 is nothing. So I'll bring down negative 9w equals, and 23 minus 5 is 18. Then negative 9 touching the w means they're multiplying. So I will have to divide by that negative 9 to create a positive 1. Negative 9 goes into itself exactly 1 time. So w equals, divide this side, 18 divided by negative 9 would be negative 2, because a positive divided by a negative is a negative. So the set is negative 2. So signs, just in case you're struggling, when you're multiplying or dividing, if you have two of the same sign, positive, positive, or negative, negative, that makes a positive sign. If you have negative, negative, or negative, positive, or positive, negative, two different signs, it's going to come out negative. This is for multiplying and dividing. Adding and subtracting just depends on what number you start with and whether you're sliding to the left for subtracting on a number line or right for adding on a number line. Okay, n divided by 3. So this n is kind of being divided by 3 here. And then minus 8 equals 7. So first we have to get rid of that minus 8. We have to work farthest from the variable and then work our way in. So when we get rid of negative 8, we'll have to add it. Negative 8 plus 8 makes nothing. Add it to the other side. So n divided by 3 equals 15. Now to get rid of divided by 3, opposite of divide is multiply. So we'll multiply by 3. So 3n over 3. 3 over 3 makes 1. Multiply this side the same way. So n equals 15 times 3 is 45. So the set will be 45. Now, it's really important to notice the difference between 11 and 12. On 11, the variable was the only thing tied up in the fraction. So we got rid of that negative 8. On number 12, this whole thing is tied up in the fraction. So we can't do anything until we clear that fraction. So this says that z plus 7 is getting divided by 5. So to undo that dividing, we will multiply up top. 5 over 5 will cancel. Got to multiply this side by 5. So then I'll end up with z plus 7 equals, and negative 3 times 5 is negative 15. Now I'll have to minus 7 to get rid of the 7. So z, I'll cross it so it doesn't look like a 2, equals, when I have negative 15 and I have minus 7 more, picture a number line. So I've got 0, negative 15. This way is minus, this way is plus. So if I'm going to minus 7 more, I'm going to end up at negative 22. So negative 22 is the solution set. All right, got a few more here. So this one, now, when we have a fraction in our problem, what we might want to do, even though it's not on the variable side, what we might want to do is multiply this by 2 so we don't have a fraction, and then multiply this side by 2, because we have to do the same thing to both sides. So on this side, the fraction cancels, and I just get negative 9 equals, when I distribute this 2, I'll get negative 6 minus 2p. And now we can work with it like we're more used to. So we work farther away from the p and work our way in. So on this right side, I'm just putting a wall where my equal sign is. On this right side, first I'll get rid of negative 6 by adding 6. So negative 9 plus 6 is negative 3 equals, and I have to be careful with my sign here. Negative 2p is what I have. So negative 2 times p. So to undo that negative 2 multiplying, I'll divide by negative 2. So unless p is already a 1, you always have to divide last to get that variable by itself. Negative 2 divided by negative 2 is 1. So we'll end up with, bring it over here, this does not divide. So it'll still be 3 over 2. But what we do know, remember, is that if we have two negatives, negative, negative, that's going to make a positive. So we have 3 halves equals p. So the solution set will be 3 halves. Okay, now for number 14 and 15, these are super important, and this will come up more in literal equations, but you can never solve a variable in denominator. So if it's in the denominator, the first thing we have to do is get it out. We cannot solve for a variable that's down there. Well, we already know how to clear this. So this says 4 divided by k. If 4 wasn't being divided by k, we wouldn't have a fraction. So to undo that division, we can multiply by k, both sides. K over k will cancel out, make a 1. So 4 times 1 is just 4 equals 5k. And now, to get k by itself, it's just multiplying to a 5. So we can divide by 5 to both sides. And we'll get k equals 4/5. So the solution set is 4/5. So the solutions can be fractions. So this one's weird with this negative j in the denominator. Can't solve for it down there. So to get rid of that divided by negative j, we will multiply by negative j to both sides. So I'm using parentheses instead of a dot just because of that negative sign. I want to keep it with that j. So I would have 2 equals, and then 10 times negative j, if that's confusing, remember that means negative 1j. So 10 times negative 1 would be negative 10j. Then we have to divide to get this negative 10 that's multiplying to the j. Get that off, so we'll divide by negative 10. That makes 1. Okay, now, j equals. 2 does not divide by 10, but we know that a positive divided by a negative will give us a negative fraction. So we have negative 2/10. But those are both even numbers. So we can actually reduce that, and we'll say j equals, if we divide the top and bottom of this both by 2, negative 1 over 5 would be the reduced version. So you have to remember, some of you have done all of this before, and some of you have never done this before. So you'll just have to make sure you ask questions. The set would be negative 1/5. And let me help you clarify ones you don't understand. If you need a few more of a certain type to try, just let me know. All right, let's see if we can use some of this to solve actual real problems. So Marcus has 3 more Twizzlers than 2 times the number Becky has. 3 more means we're going to add 3. So that means add 3. What are we going to add 3 to? We're going to add 3 to 2 times the number Becky has. So let's see. Marcus has 17 Twizzlers. Becky We don't know. So we'll call her X. But we know that Marcus has 3 more than 2 times what Becky has. So if we take Becky's and we say 2 of Becky's, 2 times Becky, and we add 3 to it, now we have Marcus. This means Marcus right here. So 2x plus 3 is Marcus. We also know that that must equal 17 because we know he has 17. So now we can solve this and we'll be able to find out how much Becky has when we know what x is. So we'll minus 3 to both sides. 2x equals 14 because 17 minus 3 is 14, and then we'll divide by 2. So x equals 7. Becky has 7 Twizzlers. Got to give it some context. What did we find out? She's lucky. I wish I had one. Alright, now we need to solve some equations that involve the distributive property. So the distributive property means that whatever number is touching the parentheses on the outside, so it doesn't have a plus or a minus in between it, but it's touching the parentheses, that needs to get multiplied or distributed to every term in the parentheses. So on 17, we have a 2 out here, and it needs to distribute to the 8 and the p. Now we're multiplying. Distributive means multiply. It just means multiply to everybody inside there. So 2 times 8 is 16. And then 2 times positive 1p will be positive 2p. So if you want to put the 1s in, you can. If you don't need to, 2 times p is just 2p. That's fine. Equals 22. And then we're off, and it's just like the other ones. So first we'll get rid of the 16 by minusing. And then we'll have 2p equals 22 minus 16 is 6. And then we'll divide to get the 2. So 2p divided by 2 makes 1p, so p equals 3. So the set would be 3. Okay, now the distributing can happen anywhere in the problem. It's not always right at the beginning. So this says m plus the 5 getting distributed. So we'll bring down the m and we'll distribute this positive 5. So positive 5 times m gives us positive 5m. Do you see how I'm using the sign with the number instead of bringing it down? And then positive 5 times negative 1 will give us negative 5. And that equals 7. So now we have to combine like terms. So anything with an m will go together. So m plus 5m. If you need to remind yourself that this is a 1, you can. So m plus 5m, 1 and 5 will give us 6m minus 5 equals 7. And now we can work on getting that m isolated. So we'll add 5 to be the opposite of minus 5. And then we'll have 6m equals 7 plus 5 is 12. To undo 6 times m, we'll divide by 6 to both sides. So m will equal 2. Set is 2. Alright, so here's the one that gets people in trouble. It's when you're distributing a negative sign. So the negative sign has to get distributed, okay? And if distributing a sign seems crazy, then what you can do is think of it as negative 1. So we're multiplying negative 1 to both things in the parentheses, because that's what's touching them, okay? The 8y is not. So we have 9 equals 8y, and then we'll be multiplying negative 1 to both things in the parentheses. So that's one to watch out for. Negative 1 times 2y will give us negative 2y. And then negative 1 times negative 3. Remember, negative times a negative will give us a positive. And 1 times 3 is 3. Then when we combine like terms that are on the same side, we don't do opposites. We just combine what we see. So 8 minus 2 will be 6y plus 3. And then we'll get rid of the adding. And then lastly, get rid of this multiplying by dividing. 6 divided by 6 is 1. Now, we don't want to just cross this one out. We can make it 1 if we want, but we'll have, oops, I'm making an arrow here. We'll have 1 equals y for our final answer. So the set is 1. Because 1y, we usually leave invisible. But we need something on this side. So 6 divided by 6 makes a nice 1. Okay, so this one's not too bad. We're going to distribute the negative 2. So 14 equals negative 2 times r, negative 2r. Negative 2 times negative 3, remember that sign goes with the number. Negative 2 times negative 3 is positive 6. Now we can finish this off. We'll minus that 6. We'll divide by negative 2. So r equals positive 8 divided by negative 2. Two different signs here will give us a negative number, negative 4. Okay. All right. This one's great. When we distribute, we'll mark this one too. When we distribute a whole number to a fraction, it always goes to the top. So 4 times 1 will be 4, and this bottom just stays the same. So it does not go to the top and the bottom. Whatever's on the bottom of it, if it had a fraction, would go to the bottom. So this is an invisible 1 down here if you want to think of it that way. So 4 times 1 on top, 1 times 4 on the bottom. And then 4 times x would be positive 4x equals 14. So this is just a 1. So we have 1 plus 4x equals 14, because 4 divided by 4 is just 1. If you think of it, you're doing 4 times 1/4. 4 1/4 would make 1 whole. So now we got to get rid of that 1. Negative 1 to both sides. So 4x equals 13. And then we'll divide by 4 to get rid of that guy. And 13 doesn't divide by 4. So, and it doesn't reduce. So that's actually our solution, is 13/4. We won't turn it to a decimal because fractions are more perfect. You don't have to round them or anything. What's going to be great is when you do a bunch of these, as they get longer and bigger like these, you won't get intimidated by them. You'll just do the steps and you'll take care of it just fine. So we've got 3x, and then we have a positive 5 getting distributed. So positive 5 times negative 6x, negative 30x. Positive 5 times 16 will be 50 plus 30 will be positive 80. And then we've got negative 136. So, like terms here are 3x minus 30x. So, when you do 3 minus 30, you're going to get negative 27x. And then, when we get rid of this plus 80, we'll minus 80. Now, we have negative 136. I'm going to bring this down here. Negative 136 minus 80 more. So that's going to get us all the way. We have a negative minus a number. We're going to get super negative down there, right? So adding and subtracting, the same signs don't make a positive. They just do whatever they do. So we're starting at negative 136 and we're minusing 80. On the number line, minusing is this way and adding is this way. So that's going to give us negative 216. And then we'll divide by negative 27. Now there's no way you're going to go as fast as me. You're going to have to pause it and use your calculator, and that's okay. I've already done these, so I know how they're going to come out. Now that makes 1, and this makes positive, negative, negative, if I'm dividing, makes positive, and 27 fits into 216 8 times, so that solution is actually 8. Looked like it was going to be a lot worse, didn't it? Alright, so here we've got 24 equals negative 3x. Now, negative 6 is getting distributed. Okay, so I'm not bringing that sign down, it's going with the number. Negative 6 times negative 2x will give me positive 12x. So that's where my sign comes from, is the result of my multiplying. Okay? And negative 6 times negative 16 will also be positive, and that's going to be 96. All right, and then we've got to combine like terms. So when we're combining like terms, we're not doing opposites. We're just doing what it says. So negative 3 plus 12 is 9. Okay, and then we'll minus 96 to both sides. So we'll have 9x equals, when we have 24 and we take 96 away from it, we're definitely going to get a negative number, aren't we? Negative 72. Then we'll have to divide by 9 to get that off the x. And a positive going into a negative is going to give us a negative 8 equals x. So negative 8. Okay, now we get a chance to distribute another fraction. So let's see, 20 equals, well actually I think we distributed to a fraction before, but we didn't distribute a fraction. So I'll show you how it works. Pretty easy. Bring down this. Now, the top goes to the numbers, and the bottom goes to the bottom. And if there isn't a bottom over here, it just goes, the 2 is just going to go under there by itself. So 1 times 30x on top, that's going to be positive 30x, and it goes over a 2. And then 1 times 40 is going to be positive 40, and it goes over a 2. So you're distributing the top to the whole numbers, and the bottom goes underneath. Okay, now, before we do anything else, if these divide, we'll actually divide them, which they do. So we'll simplify that. So we'll get negative 5x. 30 divided by 2 will give us 15x. And 40 divided by 2 will give us 20. So that's a lot easier to work with. Now we can combine our like terms. So 20 equals negative 5x plus 15. If you picture on a number line, 0, 1, 2, 3, 4, negative 5, but we're adding, right? So we're going to add 15, so we're going to go this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So we're going to end up at positive 10x plus 20. Then we can minus 20 to start isolating our variable. Ooh, this one's interesting. 20 minus 20 is 0. So we've got to have something over there. We don't want to just cancel it out. 0 equals 10x. Okay, so then we'll still have to divide to get that 10 off of there. So 0 divided by 10 is going to equal 0. So 0 is an answer too. Some people accidentally say no solution when they see 0. So remember, 0 is a number. Okay, one more here. Negative 6x. Positive 2 is getting distributed. So 2 times negative 5 will give us negative 10x. 2 times positive 15 is going to give us positive 30. And that equals negative 80. So then we'll combine our like terms. When I have negative 6, so picture that over here, negative 6, but we're going to take away 10, so we're going that way. So that's going to be negative 16x plus 30 equals negative 80. We start farthest away from x, so we'll get rid of the 30 by minusing it. Inverse operations. So negative 16x equals negative 80 minus 30 more. It's going to be negative 110. And then we'll divide by negative 16. So we know we're going to get a positive number here, negative divided by a negative. But that one doesn't actually divide. So we'll have 110 over 16. Because if you tried to divide it, you'd get a decimal like 6.8 something. So we'll leave it like this. But if we notice that they're both even, I'll bring it up here, we can reduce it. Remember? So we'll divide them both by 2 because they're both even. So we'll get x equals 110 will be 55. And 16 divided by 2 is 8. And now they're not both even anymore. And I know 8 doesn't go into 55. So we'll just have to call that good. So 55 over 8 will be our solution set. Okay. Now, what you have there is a guide. Okay. You have now in your possession notes on a lot of different little things that could happen. So you've got examples you can look up when you start working on a lot of problems by yourself. Find one. These 25 show you a lot of things that could happen. And you also have the video. So if your notes aren't good enough, you can come back to the video, which is the notes with an explanation. So go forth and conquer. We'll try some with variables on both sides tomorrow, both sides of the equation. When we have x's on this side and x's on this side, what do we do? That's for tomorrow. You're doing great.